Imagine for a moment that time isn't just, flowing past us like a river. What if it's more like an invisible ocean we're all swimming in? An ocean with currents and tides that subtly shape the very fabric of our universe. And what if these currents could literally influence what kinds of matter and energy can even exist in different places at different times? Sounds like something plucked straight out of science fiction, right? But today, we're taking a deep dive into a truly mind-bending theoretical idea, the Chronon Field Hypothesis. Our mission today is to pull back the curtain on this fascinating concept. We're going to unpack its core ideas, explore the surprisingly robust math that underpins it. And don't worry, you absolutely won't need a physics degree to follow along. We'll uncover what it could mean for our understanding of reality. We're sifting through some pretty complex research here to give you a shortcut to being well-informed about this profound theory and its potential implications. And trust me, you'll want to hear about what it calls the sieve effect. It's truly revolutionary in how it suggests the universe might literally filter what's allowed to be. Get ready for a cosmic thought experiment. So let's start with the big picture. What exactly is this Chronon field? Think of it like this. You know how a magnet creates an invisible magnetic field around it, which affects metal objects?
Right, that's a good starting point.
Well, the Chronon field is sort of similar, but instead of affecting compasses, it influences the very nature of time and the fundamental particles that make up, well, everything around us.
Exactly. It's proposed as an invisible field filling all of space. We are all, in a sense, immersed in it.
And it's not static, right? Not just a flat background.
Not at all. It's incredibly dynamic. Its strength isn't uniform. It varies across space, stronger here, weaker there. And crucially, it changes over time. Billions of years ago, for instance, the Chronon field would have been very different from what it is today.
So this omnipresent, constantly shifting field is kind of the central character in our story today.
That's right. And what's really compelling for physicists about the Chronon field is its mathematical foundation. We can think of it as a fundamental scalar field.
Okay, scalar field sounds a bit intimidating. What does that mean in simple terms?
Don't let it scare you. Think of it like a temperature map. At every point in space, there's a specific temperature value, but temperature itself doesn't have a direction, right? It's just a number.
Right.
That's a scalar. Similarly, the Chronon field has a value at every point in space-time, and that value influences things locally. Its behavior is rigorously described by what we call a relativistic wave equation.
A wave equation, like for light or sound.
Sort of, yes. It's a type of equation physicists use all the time to describe fundamental fields. It's standard physics toolkit stuff, actually.
So it's like an invisible fluctuating temperature for time itself, but it's tied into the fabric of the universe. How does the universe talk to this field then?
Exactly. The mathematics tells us that this field isn't just floating out there on its own. It's intricately linked to all the matter and energy in the universe. Imagine the universe's matter and energy creating ripples or stresses in space-time. Those stresses actually act as a source for the Chronon field.
Ah, so it influences the field's strength and how it changes.
Precisely. The field is both influencing the universe and being influenced by it. It's a feedback loop, in a way. Beautifully self-consistent.
Okay.
And yes, if we drill down to the quantum level, we'd even talk about chronons.
Chronons, like photons for light.
Exactly like that. Hypothetical tiny packets of energy that make up this field. The little bits of this temporal ocean, if you will.
Okay, an invisible, dynamic ocean of these chronons that interacts with everything. I can already see this could have some pretty wild consequences. And this brings us to what you mentioned earlier, the sieve effect. What exactly does that mean?
Well, let's stick with your ocean analogy. If the Chronon field is this cosmic ocean, then the sieve effect is what happens when particles try to swim through it.
Swim through time.
Metaphorically, yes. Some particles pass through easily while others find it incredibly difficult, almost as if they hit some kind of resistance. The field acts as a universal filter. It determines which particles can readily exist or be created in a given region of space and time, and which cannot.
A universal filter. So how does this cosmic filter actually work on a physical level? Is it like a literal net catching particles?
Not a literal net, no. But it effectively changes a particle's weight, or maybe better, its cost of existence. At a fundamental level, the Chronon field interacts with other quantum fields, the ones that describe electrons, quarks, even the Higgs boson. This interaction creates what we call a space-time dependent mass shift.
Space-time dependent mass shift. Okay, Break that down for us.
Right. It means the Chronon field effectively modifies a particle's effective mass. It's not changing the fundamental mass, but how it behaves. So if the Chronon field is strong and positive in a certain region, it's like a particle suddenly gaining extra effective weight.
Heavier.
Effectively heavier, yes. A particle that's already heavy becomes even heavier, making it much harder for it to be created or to exist stably in that region.
So in these strong field areas, the universe kind of filters out the heavier, more exotic particles, favors the lighter stuff.
Exactly. It's like a cosmic bouncer, maybe, only letting in the lightweights in those zones.
Huh. Okay, so what about the opposite?
Conversely, in regions where the Chronon field is weak, or maybe even negative, particles might become effectively lighter.
Lighter.
Or find it easier to manifest, let's say. This could allow for more massive, more exotic particles to exist there, increasing the diversity of matter possible in those regions.
This is truly fascinating, and here's where it gets really interesting for you listening. This means that the very kinds of matter and energy that can exist in our universe might not just be determined by unchanging fundamental laws, but also by where and when you happen to be. It suggests reality itself isn't uniform. The universe might have had different rules for existence in different eras or even different locations. That's a profound thought. It fundamentally alters our perception of what's possible.
And if we connect this to the bigger picture, this sieve mechanism could offer some compelling explanations for profound cosmic mysteries. One of the biggest is the early universe.
Right, the moments just after the Big Bang.
Exactly. Think of the universe as a rapidly evolving city. In its very early moments, the Chronon field would have been dramatically different, much stronger, probably fluctuating wildly. So this early city would have had entirely different zoning laws, so to speak.
Zoning laws for particles.
Kind of, allowing for very different buildings, different kinds of particles to be constructed and to thrive back then, particles that maybe can't exist easily now.
So it could explain why the universe's particle cocktail was so different back then, why certain exotic particles were common but are now rare, and how the overall composition of everything we see today came to be.
Precisely. It offers a dynamic explanation for how the universe's fundamental makeup has evolved over cosmic history. It's not just static rules. And what's more, this theory even touches upon something physicists grapple with called the information problem in cosmology.
The information problem, how does this relate?
Well, it suggests the universe isn't just passively evolving. It might be constantly choosing what can exist based on available information, almost like a complex, self-regulating system.
Like a giant computer running a simulation.
That's one way to think about it. The Chronon field, in this view, becomes an integral part of that system's operating instructions, influencing how information flows and what realities can emerge. And this isn't just hand-waving. The theory connects this mathematically. It shows how the Chronon field would directly contribute to the universe's overall energy density.
Energy density, like dark energy.
It would contribute alongside things like matter and dark energy. And that total energy density directly impacts the expansion rate of the entire cosmos, described by Einstein's Friedmann equation.
Wow, so it's not just filtering particles locally, it's actively shaping the universe's large-scale evolution, too.
That's the implication, yes. It's woven into the very fabric of cosmic expansion.
Okay, let's unpack this a bit more. We've talked about these incredible, almost sci-fi concepts. But you mentioned earlier that this isn't just a wild guess, there's robust math behind it. For us, who aren't fluent in quantum field theory, what does it mean that the math behind this is sound?
It's vital to understand this isn't some fanciful idea just scribbled on a napkin. This hypothesis leverages mathematical tools and frameworks that are already well established and rigorously tested in physics.
So it's playing by the existing rules of physics.
Exactly. It integrates concepts from general relativity, that's Einstein's theory of gravity and spacetime, with quantum mechanics, the physics of the very small, and quantum field theory, which describes how particles interact. It's built on solid ground.
So it's building on the work of giants rather than starting completely from scratch.
Precisely. It uses the same kind of equations and mathematical machinery that successfully describe everything from the behavior of electrons in an atom to the expansion of the universe. For instance, the theory specifies a total Hamiltonian. That's just a fancy physics term for the mathematical expression of all the energy in a system. This Hamiltonian includes both the standard physics we know and the influence of the Chronon field. This lets physicists calculate how quantum states evolve under its influence, ensuring things like probability are conserved, which is absolutely fundamental in quantum mechanics.
So the math checks out. It's internally consistent.
It means the theory works. On paper, yes. It respects the deepest laws of physics as we currently understand them. It hangs together logically.
That's reassuring, knowing it's not just wishful thinking. But it leads to a very natural question for us listening right now. If this field is so fundamental, shaping reality and time itself, why don't we notice it in our daily lives? Why isn't my coffee mug suddenly getting heavier or lighter depending on where I put it on the desk?
That's an excellent question, and it really comes down to scale and energy. The theory predicts that the interaction strength of the Chronon field, there's a factor, a coupling constant we call G, is incredibly weak at the low energies characteristic of our everyday world.
So it's there, but the effect is tiny.
Think of it like gravity. It's always present, right? But you don't feel the gravitational pull of your coffee mug on your hand because it's absolutely minuscule compared to the pull of the entire Earth.
Good analogy.
The Chronon field's influence, similarly, is predicted to be just too negligible for us to detect with our current technology or in our immediate environment. It gets drowned out.
So it's just really, really subtle in our normal experience.
Exactly. Its effects would only become significant, really noticeable, under the most extreme conditions. Imagine energies near the Planck scale, that's unimaginably high energy.
Way beyond anything we can create in labs right now.
Oh, absolutely. Or during the very first fractions of a second of the universe, right after the Big Bang, when everything was incredibly energetic and dense. So its impact is potentially profound, but it's most impactful at the most extreme ends of the cosmic spectrum, way far removed from our immediate human experience.
This has been an incredible journey into what's possible, theoretically speaking. So where does the Chronon Field Hypothesis stand today? Is this simply a wild, fantastical idea, or is it genuinely on the path to becoming accepted science?
Well, let's be honest about its current status. This is currently theoretical speculation. It's not yet proven fact. We need to be clear about that. But, and this is a big but, it's extremely well-constructed theoretical speculation. It's the kind of idea that sparks immense excitement among physicists because it attempts to answer some of the universe's biggest, most vexing questions using a robust scientific approach.
That's absolutely the right way to frame it. What elevates it beyond mere conjecture, beyond just a cool story, is its internal mathematical consistency the equations hold together, as we discussed. It's also built firmly on established physics. It's not inventing completely new rules willy-nilly, but integrating existing pillars of our understanding in a novel way.
Makes sense.
The ideas connect coherently, forming a logical and, frankly, quite expensive framework. And critically, it could potentially be tested. That's key. That could be tested part is key. So what are the missing pieces then? What still needs to happen for this theory to move from fascinating speculation to, established science?
Fundamentally, we need direct experimental evidence. That's the gold standard in physics. We haven't directly detected this field or its specific effects yet.
No smoking gun.
Not yet. We also need more specific, testable predictions. A really strong theory shouldn't just explain what we already see, but it should also predict new phenomena that we can then go out and look for. And perhaps the biggest lingering question, the why of it all, remains. What is the fundamental physical motivation for such a field to exist in the first place? Why should it be there as part of our universe's fundamental laws? We don't have a definitive answer to that yet.
So consistency, testability, evidence, and a deeper reason for existing. That makes sense.
Think of it like this, maybe. Before Einstein, the idea that time could slow down depending on your speed, or that massive objects could literally bend the fabric of space, that seemed utterly bizarre, right?
It's totally counterintuitive to everyday experience.
Completely. But those crazy ideas,
Right.
based on elegant mathematics, turned out to describe reality with astonishing accuracy. The Chronon field might be similarly revolutionary, or it might turn out to be an incredibly interesting dead end, an intellectually stimulating exercise that just doesn't match reality. And that's okay. That's simply how science works.
Yeah.
We propose bold ideas, we rigorously test them against observation and experiment, we refine them, or sometimes we have to humbly discard them. It's a messy process, often painstaking, but ultimately is incredibly progressive and rewarding.
So we've taken quite the deep dive today into the Chronon Field Hypothesis. We've seen it as this invisible, dynamic influence potentially shaping reality, offering explanations for cosmic evolution, and built on a foundation of robust, standard physics. It's really a remarkable testament to human curiosity and a relentless drive to understand the cosmos, isn't it?
Absolutely. And whether or not this particular theory ultimately proves correct, what it absolutely demonstrates is how scientists continue to push the boundaries of our understanding. We're relentlessly asking fundamental questions about the very nature of reality itself. The true beauty of theories like this, I think, is that they invite all of us, scientists and non-scientists alike, to imagine the universe as far stranger, more dynamic, and infinitely more wonderful than our everyday experience might suggest.
Hmm.
And sometimes, just sometimes, that's exactly what the universe turns out to be. It encourages you, listening now, to continue pondering the hidden strangeness, the unseen forces, and the profound possibilities that might be at play just beneath the surface of what we perceive. Keep that sense of wonder alive.